Okay guys, welcome to lesson 8.4. Just as a little warm-up, why don't somewhere in your packet, maybe on the back of section 8.3, I'd like you to do this. I'd like you to draw a parallelogram and its diagonals. And I'd like you to take a moment to think about what kind of triangles are formed. So why don't you press pause and do that. Okay, so knowing that this is a parallelogram, we know that we have diagonals that bisect each other. So that diagonal is congruent, this diagonal is congruent. And so we have kind of a set of left and right triangles. And can't we say that the left triangle is going to be congruent to the right triangle by side, 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 or side angle, side, whatever method we want? We know that we have the left and the right triangle are congruent. And we also know that this top and bottom triangle are going to be congruent, again, by side, 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 angle, side. So what I'm going to say is that we have two sets of congruent triangles when the diagonals of a parallelogram are formed. All right, so let's start our notes. And I'm going to start these notes. The first thing I'm going to do is I'm going to define all of these terms. So rectangle, rhombus, and square. I know you know what those are, but we really have to come up with some really good definitions. If we think about a rectangle, what's special about it? Well, it's special because it has 4 right angles. So a rectangle is just going to be a quadrilateral with 4 right angles. In other words, it's equiangular. I want to compare that. I'm going to jump down to the definition of a rhombus. So a rhombus, again, is a quadrilateral, but it's a quadrilateral, and I think most of you know this, with 4 congruent sides. In other words, it's equilateral. Okay. And what we do when we talk about a square is, well, a square is kind of the combo of both. It's a regular quadrilateral. It's got equal angles and equal sides. Okay. So now that we have the definitions down, I'd like you to go through and do the drawing. So why don't you press pause and draw a very neat rectangle and tell me something about its diagonals. So draw a rectangle, draw the diagonals, and then kind of figure out the same thing we did with a parallelogram. Kind of figure out about the types of triangles that are formed. So press pause, and why don't you do the 3 drawings, the rectangle, the rhombus, and the square. Do the 3 drawings now. Okay, so if we get back, I drew a rectangle. My diagonals are not going to be terribly neat because, quite honestly, it's very hard to do with this program. But if I draw the 2 diagonals in there, well, I end up looking at them. Can you make a guess about those diagonals? And it's that the diagonals are congruent. The diagonals are congruent there. Okay, so let's think about it. A lot of you already knew that a rectangle is actually a very special type of parallelogram. So if it's a parallelogram, we know the diagonals bisect each other. And we also know, we can just tell, that in a rectangle the diagonals are congruent to one another. So doesn't that make each half of the diagonal, they're all congruent. So now if we think about these triangles that are formed, well, once again, the top and the bottom triangle are going to be congruent to one another. And the left and the right triangle are going to be congruent to one another. But more importantly, all of those triangles are isosceles. So I'm going to say that when we draw the diagonals, 2 sets of congruent isosceles triangles are formed. Okay. All right, so now let's move on to a rhombus. If we draw the diagonals of a rhombus, and again, my apologies that this isn't terribly neat, well, can't you just tell that those diagonals are perpendicular? Okay, so we have perpendicular diagonals. I'm going to see if I can mess with this a little bit. I'm really not sure if I can, but can. So we know that the diagonals are perpendicular. Okay, so now let's think about these triangles that are formed. Well, once again, we know it's a type of parallelogram, and so we know that we have two sets of congruent triangles. We know that the way I drew it, this triangle and this triangle are going to be congruent, and let's see, the lower left and the upper right triangle are going to be congruent. But taking a look at those are all right triangles. Now remember, everything that holds true about a parallelogram is going to hold true about a rhombus. So we also know that the diagonals bisect each other. We know by the definition of a rhombus that all of these sides are the same. So you're kind of coming to the conclusion that these four triangles that are formed are going to be four congruent right triangles. Those are four congruent right triangles that are formed when we draw a rhombus. Your book also adds that a rhombus is going to actually, the diagonals of a rhombus are going to bisect. So let me see if I can do this. The diagonals of a rhombus, so this diagonal right here and this diagonal right here are actually going to bisect the angles of the rhombus as well. But I don't know if I'm going to make a special point of that. I just like to remember that all four of these right triangles are going to be congruent to one another. All right, let's move on to a square. Let's draw the diagonals of a square as neatly as we can. And what we know about a square, if you haven't figured it out already, well, a square is kind of a combo of a rhombus, the sides are congruent, and of a rectangle, meaning all of the angles are right. So when we draw those diagonals, we can tell that we have four congruent right isosceles triangles. So basically, it's kind of like all of the above. All right. And that's about it. That's about it. So I'm thinking that the homework tonight is pretty easy, and so that shouldn't take you very long. Hopefully you have some nice diagrams to go with. Oh, I forgot about the bottom part of this. So let's turn. And as we saw before, I forget where we were. I just tried to turn the page back, and I can't do that. As we saw before, a square is made up of four really isosceles right triangles. So all of those angles are 45 degrees, and we can use our 1:1 to √2 ratios on it. Okay, so that's about it. And you have homework tonight, so hopefully you have some nice, neat diagrams to go with, and you have homework D tonight. So I will see y'all tomorrow. So the diagonals of a rectangle, well, the diagonals of a rectangle are congruent. The diagonals of a rhombus are perpendicular. And then we have this theorem, each diagonal of a rhombus. Your book kind of makes a point to say that each diagonal of a rhombus bisects the rhombus angles. Now also remember that rectangles and rhombi are forms of parallelograms. They're actually special types of parallelograms. So everything that's true about a parallelogram, meaning the diagonals bisect each other, the opposite sides are congruent, the opposite angles are congruent, the adjacent angles are supplementary. Everything that's true about a parallelogram is also true about a rhombus and a rectangle. Now, what does this say about the diagonals of a square? And again, this is all of the above. Everything that's true about a parallelogram, a rhombus, and a rectangle is also true about a square. And more importantly, as